Hello viewers, today in this program we will discuss the transportation problem and its solution. Here we will discuss the problem of demand and supply at different origin and destinations in minimum cost. The transportation model of LPP deals with the transportation of the product available at several sources to a number of different destinations. The origin of transportation model was in the study of F. L. Hitchcock in 1941. In 1947, T. C. Koopmans presents optimum utilization of the transportation system. The transportation is to fulfill demand and supply at different sources and destination in minimum cost. The transportation model suggests the transportation path to fulfill demand on different destinations with minimum cost. Here we have shown in this picture A, B, C are 3 sources and destinations are P, Q, R. We have 3 paths from A to P, Q, R, 3 paths from B to P, Q and R, 3 paths from C to P, Q and R. Now we will discuss the mathematical model of the transportation problem. The mathematical model of transportation problem is minimize Z is equal to sigma I is equal to 1 to m, sigma j is equal to 1 to n, C I j into x I j subject to sigma j is equal to 1 to n, x I j equal to a I, that is I is equal to 1 to dash 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 m, and sigma I is equal to 1 to m, x I j is equal to b j, where j is equal to 1 to dash 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 n, and sigma j is equal to 1 to n a I is equal to sigma I is equal to 1 to m b j is equal to x I j. This is the mathematical model of the transportation problem. Here the constraints are linear, therefore it is under linear programming problem. The matrix form of transportation problem is as shown in this table. The origin O1, O2, OM in first column represents the resources, and the first row D1, D2, Dn represents the different destination. Here in the main table we have in any cell X and C are 2 entries. X represents the cost of the cell and C represents the allocation to the cell. Here in the last row represents the requirement at these destinations, or we can say demand at these destinations represented as B1, B2 and so on Bn. In the last column the availability, that is the supply from the origin O1, O2 and so on, represented by A1, A2 and Am. Now we will discuss the solution of transportation problems. To solve the transportation problem, we find the basic feasible solution. The basic feasible solution can be obtained by using any of the following 5 methods. Method 1, northwest corner method. Method 2, row minima method. Method 3, column minima method. Method 4, least cost method, and method 5, Vogel approximation method. This method is also called penalty or regret method. Here we will discuss these methods by taking example one by one. In the first method, northwest corner method, we first allocate the maximum unit to the northwest corner, that is the first cell. Then if the row is exhausted, move to the second row, and if the column is exhausted, move to the second column. Move in the same way until all the availabilities and requirements are fulfilled. Example here is the table represents the transportation table in which O1, O2, O3 are 3 origins and D1, D2, D3, D4 are 4 destinations. Demands here is in first destination 7, in the second 5, in the third 3, in the fourth 2, and supply here at first origin 6, second origin 1 and third origin 10. We allocate the maximum value here in the first cell as 6. Now, this first row is exhausted, so we come to the second row. In the second row, we enter 1 at the first cell, and then D1 column is exhausted, so we move to the second column D2. In this column, we put 0 here, since simultaneously the second row is exhausted. So, we come to the third row and we enter 5 in the cell of D2O3, then 3 to the cell D3O3 and 2 to the cell D4O3. The cost of initial basic feasible solution is obtained as Z is equal to 6 into 2 plus 1 into 1 plus 8 into 5 plus 15 into 3 plus 9 into 2, that is equal to 116. In this method, we have entered the allocation to the first cell 6 value, the first cell of second row 1 value, second cell of second row 0 value, then in the third row second cell 5 value, third cell 3 value, then in the last cell 2 value to get the minimum of transportation cost Z. It is 116. Now, we will discuss the second method, that is row minima method. Choose minimum cost cell of first row, allocate maximum unit possible. Then if the row is exhausted, move to the next row, otherwise move to the next to the lowest cost cell of the row. We will discuss the row minima method by taking the example as follows. Here is the example of transportation problem in which 3 origin and 4 destinations, supplies are 6, 1 and 10, demands are 7, 5, 3 and 2 at different destinations. Here we start with first cell, we allocate 6 to that cell. So, the first row is exhausted. So, we come to the second row and its minimum is here D2. We allocate 1 to this row. Now, again this row is exhausted. So, we come to the last row and minimum value here is 5. We allocate maximum possible number 1 here, then next to it is 8. In the cell D2 we allocate 4 here, then the cell D4 we allocate 2 here, then the cell of cost 15 we allocate 3 here. In this way, the cost of transportation, that is basic feasible solution, becomes Z is equal to 6 into 2 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2, that is equal to 112. Now, we will discuss the third method, that is column minima method. choose the minimum cost cell of the first column, allocate maximum unit possible, then if the column is exhausted, move to the next column, otherwise move to the next to the lowest cost cell of the column. Here I will explain the method column minima by taking the following example. In this example, we have 3 origin and 4 destination. Here supply are 6, 1 and 10 at origin O1, O2, O3, and demands at the different destination are 7, 5, 3 and 2. Here we allocate the first in second row of D1 the number 1. Then since second row is exhausted, we move to the second minimum value of the cost at D101, we allocate 6 to this. So, the first column and first row simultaneously exhausted. Then we come to the second column, in which we allocate 5 in the cell value 8 with D203. Then we come to the third column and allocate 3 in the cell D303. Then we allocate 2 to the cell D403. So, we find the cost of transportation, that is basic feasible solution, as Z is equal to 6 into 2 plus 1 into 1 plus 8 into 5 plus 3 into 15 plus 9 into 2 is equal to 116. Now, we will discuss fourth method of finding basic feasible solution, that is least cost method. Choose lowest cost cell and allocate maximum possible unit. Then next to the lowest cost cell, allocate maximum possible unit, and so on. We will allocate all the destination and resources, availability and demand. I will explain the method of least cost by taking the example as follows. Here is the example of transportation in which 3 origin and 4 destination. The supply are 6, 1 and 10 at the 3 origin, and demand at the 4 destination are 7, 5, 3 and 2. Here we allocate 1 at the cell D202, that is minimum cost cell. So, the second row exhausted. Now, in the remaining one, we have the least cost cell is D101. We allocate 6 to this, so that the first row exhausted. In the remaining part, we have least cost cell as D103 with 5 cost. We allocate 1 to it, then we allocate 4 to the cell D203, then we allocate 2 to the cell D403, and then 3 to the cell D303. This way we find the cost of transportation, that is basic feasible solution, as Z is equal to 6 into 2 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2 is equal to 112. Now, we will discuss the fifth method of finding basic feasible solution, that is Vogel approximation method. In this method, we enter the difference of the smallest and second smallest element of each row and each column and put the difference in the square bracket. To allocate cell, enter in row or column having maximum difference. The maximum possible unit to the cell of least cost in that row or column. Then write remaining cost in matrix and repeat the process. The Vogel method is based on the difference of the minimum and next to the minimum cost of the row or column. Here we indicate the difference of the minimum and next to the minimum of every row in front of the row and of every column below the column, and find the maximum of this difference to enter the row or column as follows. In the table 1 of the transportation table, we have 3 origin and 4 destination. Here are supply 6, 1, 10 and demands 7, 5, 3 and 2. Here we have calculated in the last column as the difference of the lowest and next to the lowest value of the cost. In the first origin is 1, in the second origin is 1, in the third origin it is 3. Similarly, the difference of the lowest and next to the lowest column wise, we have calculated di. In the last row it is represented as 1 in D1, 3 in D2, 5 in D3, 6 in D4. Here the value 6 is maximum, therefore, D4 is the entering column and the minimum of this column is at D4O2, that is second row, fourth column cell. We allocate 1 to this, so that the second row has been exhausted. For the next table, we will put only the first and third origin in the table as follows. Table 2. Here are 2 origin 1 and 3, 4 destination D1, D2, D3, D4, supply here 6 and 10, demand here 7, 5, 3 and 1. The difference of the lowest and next to lowest in the row 1 is 1, in the row 3 is 3, in the column 1 it is 3, in the column 2 it is 5, in the 3 it is 4, in the 4 it is 2. The maximum value of the difference here is in the column D2. So, we enter in D2, the minimum value cell here is D2O1 with cost 3. We allocate 5 to this. In the next table, we will form the table without this column D2 as follows. The table 3 here is with origin O1 and O3 and with the destination D1, D3, D4. Supply here is 1 and 10, demand here are 7, 3 and 1. The difference of the lowest and next to lowest term here in the first row is 5, in the third row is 4. In the column D1 it is 3, D3 it is 4, in the column D4 it is 2. Here is the maximum value of the difference in first row. So, we enter in the first row and choose the minimum cost. Here is D1O1 is the cell with minimum cost. So, we allocate 1 to this. Therefore, the first row is exhausted. Now, we will form the next table with the only third row as follows. Here is the table 4. There is only origin O3 and 3 destination D1, D3, D4. We allocate the maximum possible unit 6 to the minimum cost cell D1O3, then the 1 to the cell D4O3 and 3 to the cell D3O3. This way we have allocate all the cell to fulfill the demand and supply, and we find the following table, that is the combined form of the table 1, 2, 3, 4. Here in this table there are 3 origin and 4 destination. The allocations are here in the first cell D1O1 the number 1, in the cell D2O1 the entry 5, in the cell D4O2 enter 1, in the cell D1O3 the 6, in the cell D3O3 3, in the cell D4O3 1. This way the cost of transportation basic feasible solution becomes Z is equal to 2 into 1 plus 3 into 5 plus 1 into 1 plus 5 into 6 plus 15 into 3 plus 9 into 1 is equal to 102, which is evidently the least cost of transportation found by the different methods. Therefore, the Vogel method is the best method of finding basic feasible solution of any transportation model. Now we will discuss the optimity test of the transportation problem. Optimity test can be performed only on that basic feasible solution in which 2 conditions are fulfilled. Number 1, number of allocation is m plus n minus 1, m here is number of row and here is number of column, and the second condition is all the allocation should be in independent positions. A simple rule for the allocation to be in independent position is that it is impossible to travel from any allocation back to itself by a series of horizontal and vertical jumps from one occupied cell to another without a direct reversal of route. If the allocation are independent, then the problem may be improved by modified method, that is also called MODI method of transportation. Today in this program, we have discussed the transportation problem and its solution by various methods. We have discussed 5 methods in which Vogel method is the best one. I have explained the method by taking the example. I hope you have enjoyed the lecture. Thank you.